This is an introduction to right triangle trigonometry. Trig is the study of reference angles. The reference angle is the angle that you are looking from. So if I am looking from the 60, I'm looking at the adjacent, which is the shortest, and I'm looking at the opposite, which is the square root of 3. If I'm up here looking from the 30, I'm looking at the opposite of the 30 is the shortest, the 1, and the adjacent is the square root of 3. The side opposite the 90 is our hypotenuse. Now we'll never use the 90 degree or the right angle as our reference angle. We will only use the 30 or 60, basically the smaller angles. Now we say sine, cosine, and tangent of theta. Now theta is an angle, whatever the angles we're looking from. So if I say sine of 30 or sine of 60, that means I'm looking from that angle. Now one way of remembering sine, cosine, and tangent is with SOHCAHTOA, sine, cosine, and tangent. Sine is the opposite over the hypotenuse. So for example, if I wanted sine of 30, I'm going to look at the 30-degree angle. And it says opposite. Well, what is opposite of the 30? The shortest side is opposite of the 30, which is 1. What is the hypotenuse? The hypotenuse is the 2. So I would write opposite, which is 1, over the hypotenuse, which is 2. Next is cosine. Cosine is the adjacent over the hypotenuse. Well, what is cosine of 30? The square root of 3 is adjacent to the 30. We know the adjacent because you have to draw a curved line. So the adjacent is square root of 3, and the hypotenuse is still 2. That doesn't change. So cosine of 30 would be the square root of 3 over 2. Last is tangent. Tangent is the opposite over the adjacent. So if I want to find tan of 30, I say, well, what is opposite of 30? The shortest side. And what is adjacent to 30? The square root of 3. That gives me 1 over the square root of 3. Now there's a problem here. We can never ever have a square root in the denominator. Thus we have to do some extra work. If you remember something called rationalizing the denominator, it means you have to multiply the bottom of the denominator times whatever the radical is, in this case square root of 3. When working with fractions, whatever you do the bottom, you do the top. Gives you the square root of 3 over the square root of 9, because 3 times 3 is 9, and the square root of 9 is simply 3. So tangent of 30 is 1 over the square root of 3, but we have to do some extra work, and that gives me the square root of 3 over 3. Now we can go back and do all of these again, but from a different reference angle. So if instead of doing sine, cosine, and tangent of 30, we want to do sine, cosine, and tangent of 60, we can go back and do that. Sine of 60, if I'm looking from the 60, the opposite is the square root of 3, and the hypotenuse hasn't changed. Next, cosine of 60. So if we use 60 as our reference angle, the adjacent is the shortest, and the hypotenuse is still the hypotenuse. And last, tan of 60. The opposite of the 60 is the square root of 3, and the adjacent is the 1. That would give us the square root of 3 over 1, which can be reduced to simply the square root of 3. One thing I want you to notice before we continue is that when you switch the reference angles from 30 to 60, sine and cosine switched. So they're still opposite over adjacent, but since we're looking from a different angle, they are the same numbers. So sine of 30 was 1/2, and cosine of 60 is 1/2. Now there are 3 more trig functions that you need to know: cosecant, secant, and cotangent. These are the reciprocals of sine, cosine, and tangent. The first one, cosecant, you simply take 1 over sine theta. Well, what does that mean? It means you're going to have 1 over the opposite over the hypotenuse. Again, what does that mean? What that does is it flips it upside down. So instead of having an OH, you have an HO. So cosecant is sine upside down, H over O. Next, secant. Secant is 1 over cosine. That means you're going to have 1 over the adjacent over the hypotenuse, which means instead of an AH, you're going to have an HA, hypotenuse over adjacent. And cotangent, I think this is pretty self-explanatory. It's going to be 1 over tan, which is simply going to give you 1 over the opposite over the adjacent, which equals the adjacent over the opposite. So cosecant, secant, and cotangent in that order. You just take sine, cosine, and tangent, and flip them upside down. So if I was to take the same picture that we were using before and I wanted cosecant of 30, that would be the hypotenuse over the opposite. 30, the opposite is 1, the hypotenuse is 2. So 2 over 1, which is simply 2. Next for secant, if I want secant of 30, then it would be the hypotenuse over the adjacent. Well, at 30, the hypotenuse is still 2, over the adjacent is the square root of 3. Now, we talked about this before. We can't have the square root of 3 on the bottom, so you need to rationalize the denominator. It looks like this, which gives you 2 square root of 3 over 3. And last but not least, cotangent. If I want cotangent of 30, it's going to give me the adjacent, square root of 3, over the opposite, which is 1, which simplifies to square root of 3. So there are 6 trig functions, sine, cosine, tangent, and then you flip those first 3 over to get the second 3, cosecant, secant, and cotangent. Next, I want to talk about some operations or some different ways of seeing these. They'll come in handy, so you'll need to make sure you know the answers to these. Next, first, tangent. Tangent can also be written as sine over cosine. So tangent and sine over cosine are the same thing. The question is why? Sine is simply opposite over hypotenuse, and cosine is adjacent over hypotenuse. Whenever I divide fractions, we invert and multiply. Now I can cross cancel, and that leaves me with O over A. Well, what is opposite over adjacent? We know opposite over adjacent is the same thing as tangent. So if they were to give you something, what is sine divided by cosine? You're going to go, I have no clue. But you probably don't. I don't blame you. What you need to do is switch it to what letters they are, opposite, adjacent, hypotenuse, and then do the simple math. Once you do the simple math, you can easily see that sine divided by cosine is O over A, which is tangent. And think about it. Cotangent is the same thing as tangent flipped upside down. So what would cotangent be? Simply cosine over sine. Next, what if they make you multiply these? I have cosine times tangent. I have no clue, and I don't blame you. But you do know that cosine is adjacent over hypotenuse. You also know that tangent is opposite over adjacent. Since those are multiplying, you know that opposites can cancel. I have adjacent cancels out, and that's going to leave me with an opposite over a hypotenuse. Well, what is opposite over hypotenuse? You should know that opposite over hypotenuse is simply sine. So if they say, what is cosine times tangent, you're going to tell me it's sine. And I don't expect you to memorize those. I expect you to know how to find them. All right, next, sine over tangent. Well, we know that sine is equal to opposite over hypotenuse. Tangent is equal to opposite over adjacent. We invert and multiply, so that gives me cosine x. Now, if I was to flip that upside down, what would you get? You'd get secant of x, because tangent over sine, because cosine flipped upside down is secant. So sine divided by tan, you get the idea. Now, they want the 6 trig functions using angle x as a reference. Before we can start, we need to know what our hypotenuse is. You should easily be able to figure out the hypotenuse based off of the Pythagorean triples, which you have memorized from the last video. This is a 5, 12, 13 right triangle. If you don't know how to find the missing side, you can always use a squared plus b squared equals c squared. However, I strongly suggest memorizing your Pythagorean triples. First, they want sine. Sine of x is equal to the opposite over the hypotenuse. Well, the opposite is 12, the hypotenuse is 13. Cosine of x is the adjacent over the hypotenuse. Now remember, the adjacent is the one next to you. The adjacent is the one you have to draw the curved arrow to. From the x, the 5 is the adjacent, and 13 is still the hypotenuse. Tangent of x is opposite over the adjacent, which gives you 12 over 5. So those were the first 3. Now we need to flip these upside down to get cosecant, secant, and cotangent. Cosecant of x is simply sine flipped upside down, h over o, so 13 over 12. Secant of x is cosine flipped upside down, which would be 5 over 13. Cotangent of x is tangent flipped upside down, so 5 over 12. So these are your 6 trig functions using x as the reference angle. Next, I want you to find cosecant if tangent theta is equal to 3/4. They didn't give you a triangle, so draw your own. It's a right triangle. We don't know which angle theta is. It doesn't really matter. Tangent is opposite over adjacent. So that means the opposite is going to be 3 and the adjacent is going to be 4. Problem is cosecant is looking for the hypotenuse and the opposite, which means I still need to find our missing hypotenuse. Again, know your Pythagorean triples. This is a 3, 4, 5 right triangle. If you didn't know that, you could always use Pythagorean theorem to find the missing side. I strongly suggest memorizing your Pythagorean triples. Cosecant of theta is the hypotenuse over the opposite. So the hypotenuse is 5 and the opposite is 3. When they ask you to find cosecant theta, you'd say cosecant theta is equal to 5/3. If they don't give you a triangle, draw a triangle and fill it in. We have another one here, and this time we have one side that's 1, another side that's 4, but we don't know the missing side. Unfortunately, this is not a Pythagorean triple, so we need to use a squared plus b squared equals c squared. I know that the missing side is the c because it is opposite my 90-degree angle, or you can call it the hypotenuse. Your missing side is the square root of 17. Now what I want you to do is pause the video real fast and then find those 6 trig functions on your own. Come back to see if you got them right. We have sine theta is the square root of 17 over 17. Cosine is 4 root 17 over 17, and tangent is 1/4. Now, why do I have the roots on top and the 17s on the bottom? Remember that rationalizing denominators. So, for example, this one, cosine theta was 4 over square root of 17, but I had to rationalize the denominator. And that's how I got 4 root 17 over 17, is because I had to multiply top and bottom by the radical of 17. It's not all going to be labeling. Some of these you're actually going to have to do some solving. So they want you to find the length of x. So let's take a look at what we have. We have angle A. We have the opposite of angle A, and they want us to find the adjacent. So we have the opposite, and they want us to find the adjacent. Well, what is opposite over adjacent? That is simply tangent. So you will say tangent of, and what is your angle? 37 is equal to the opposite, which is 33, over the adjacent, which is x. And then you need to solve for x. And that gives you x is equal to 33 divided by tangent of 37. Now you take that and you plug it into your calculator. They want you to answer to the nearest tenth, so you're going to say the missing side, x is equal to 43 points, and I got 7925. They want the nearest tenth, which gives you 43.8. Now this is very important. Somewhere on the top of your calculator, you might see something called DEG, or RAN, or GRAD. You want the DEG. It's called degrees. If your calculator is not in degrees, then you will get these answers wrong. So make sure your calculator is in degrees. Another one, it says complete the triangle. That means I need the missing angle and I need the 2 missing sides. First, let's do the missing angle. Triangles have 180 degrees. All triangles have 180 degrees. There's already a 90 degree there and there's already a 15. So 180, take away 90 is 90, take another 15 away and you're left with 75. So we found the missing angle, 75. Now we need to find the missing sides. I'm going to use sine because most people tend to use sine. Sine of 15 is equal to the opposite, which is 10.2, divided by our hypotenuse. And we don't know what the hypotenuse is, so that's why we're finding it. Then you do the math. And plug it into your calculator. The hypotenuse is 10.2 divided by sine 15, which then is equal to 39.41. They didn't tell us how many decimal points, so I'm going to leave it at 2. Next, I need to find the side on the bottom. I'm just going to go ahead and call it side x. We have a couple options how we're going to use this. I personally am not going to use the 39.41, and the reason I'm not going to use that number, it's a number that I found. So if I made a mistake, then I don't want to miss the next part of the problem also. So I'm still going to use the 10.2, and we can use either the 15 or the 75. I'm pretty sure I got the 75 right, so I'm not going to worry about that. We'll start with the 15. We have tangent is equal to 10.2 over x, and then we're going to solve. And you're left with x is equal to 10.2 divided by tan 15, which is equal to 38.07. Now there's something I want to point out here. Is there more than one way to do this? And the answer is yes. There's actually two other ways you can do this. Now I want you to see, I had 10.2 and I had 39.41. Could I have used a squared plus b squared equals c squared? Yes, you totally could have used the Pythagorean theorems. Or is there another way to use the trig to make your life a little bit easier? And this is what I mean. Instead of using tangent of 15, why don't we use the other reference angle, 75? When I use 75, I need to find the opposite, which was x, and the adjacent, which is 10.2. Now, how is this easier than the other tangent? Watch. By using the other reference angle, I was able to have my variable on top, and that let me solve the problem in a couple less steps. So is it a little bit easier than what I did in the top right? Yes. Is it going to make a huge difference? No. It all depends on how good you are with your algebra, but it can be helpful.